Okay, yesterday we were trying to create a tiller component, the initialization between the Jenkins server and the Google Cloud, right? So here means so this is our Jenkins server and this is our cluster, and here we are trying to create a tiller component. Okay, so from here whenever we are doing Helm init service account tiller, we are getting some errors. So the problem is, let me try once again so that I can get that error. This is the Jenkins server I was using. We need to install gcloud inside this Jenkins server. If you remember, we when we installed created cluster in the Google Cloud, to access it we used gcloud, right? So that should be installed inside the Jenkins server. And to install that, the prerequisite is Python some 2.7 version. So by default in the operating system, you are going to get 2.6 version. So it is not compatible. Again, you need to upgrade that Python version. Okay, then it will work. So what I thought, instead of doing all these mandatory steps, we can use our AWS bare metal cluster. Okay, so simply we can connect and we can do the things. So this was the command we were trying to execute from Jenkins user. So if you see here, USR lib Google Cloud SDK bin gcloud. This is a command, gcloud command. This will get when you install Google Cloud. So it is telling no such file or directory. So to connect the Google Cloud. So we need to get gcloud should be installed inside this. So to install this gcloud, we need to have Python version. You see 2.7.6 is there. Okay. So when we try to install Google Cloud SDK, it is telling some Python package is this one, and is expecting some other package, Python 2.6.9. Version is showing 2.7, but here package is showing 2.6. Okay, so that is a problem. That's the reason we can use our we can upgrade this, whatever the version it is expecting, we can upgrade it. But again, we may get some other problem. So instead of wasting time, so we have another cluster, right? See, cluster is anything is same, only the way we are connecting is different. The remaining thing, everything is same. So we have already the bare metal cluster with us. So what I'm going to do, I'm going to copy the config file of this cluster to the Jenkins server. Okay, and then we'll do the same initialization. So if we log into the master server here, So now connected to the cluster which is created in the AWS bare metal. Now kubectl get pods -n kube-system. Tiller is already available here. So if you see kubectl get deployment -n kube-system. So this is already available. So what I'm going to do, kubectl delete deployment. This is a deployment name -n kube-system. So again we are going to recreate it. So if we check, tiller pod is not available. Now cat etc kubernetes admin.conf. So this is a file. So this file we need to copy and in this machine vi.kube config. So I'm deleting everything from the config file and adding the new information inside this one, bare metal cluster information. Okay, and now if you check Helm version, could not find tiller. So it is telling, means it did not establish connection to the cluster, right? So just we copied that. So now what I'm going to do, I will execute the same command, this one. We'll see what will happen. Okay, so what it's telling, tiller is already installed in the cluster. So what I'm going to do, I'm going to delete this one, rm-rf dot helm. Now again I'm going to do this. Tiller is already installed in the cluster. Okay, it got deployed. If you see 49 seconds ago, it got deployed. So this is how easily we can work with this one. The Jenkins server, I executed this one. So this is the step of the previous class, like when we are configuring the Jenkins server, during that time we completed this. Okay, but we were trying to deploy the same thing on the Google Cloud, but it's lengthy process. So instead of that, now I'm thinking do the same on the bare metal cluster itself. Okay, so because it's expecting a lot of other prerequisites, but if it in the bare metal concept, it is not asking anything, but only thing is to configure this in the bare metal, we were using T2.medium and T2.small servers, which are chargeable. Okay, so now this is ready, and CA job was completed, and it's created a artifact, and it's the Docker image, and the Docker image is available here now, right? So the Docker image is available here. Now we need to execute the CD job. Now we'll discuss about the CD job. Okay. So what we are going to do, let me take this Jenkins server, how to configure the CD job. This one. So now I'm going to configure CD job. CI job is separate. See, in your organization, it depends whether they are asking for continuation CI CD in a single job, or is it in the separate jobs? CI separate, CD job separate. So if it is a continuation, then after this creating image, then the continuation, the remaining steps. Anyhow, it's a Jenkins file. In CD also, you are going to configure Jenkins file. The Jenkins file, what are the steps are there that need to be added inside the CI job itself. Very simple. Okay. So it's up to you, like your organization demands how they are expecting. Mostly it will be not uh, CI/CD will be in the same job, because if developers done some changes in the code, and immediately if the code check-in happens, automatically Jenkins will trigger a job and it will do CI. But whatever changes has been updated on the code, and the CI job is executed and it's created var file and it's created Docker image, immediately if you are going and deploying on some environment, okay, means it is changing the environment. So someone might be using that environment, whether it may be testing environment or whether it may be develop environment. Some application guys might be testing that. Okay, if you all of a sudden changes that, then again they don't want that particular change should be applied for their testing. They are doing some testing on some functionality or whatever it may be. So if the changes has been applied, then again they need to test this. They did not test the old one. So that's why CD job will be not triggered along with the CI job. Okay, because we will have different environments, staging environment, UAT environment, and develop environment, and pre-pro environment. So in these environments, we will not do CI/CD together. Okay, so whenever we want, we will go with specific version to deploy on the environment, so that testing team, functional team can do the testing on their environment. Okay, so that's why I configured separate jobs for CD also. So now, before configuring this one, let me go to the GitHub repository where my Helm chart is available. So here also we are using Helm chart. For CD job also we are going to use Helm charts. Okay, so now in this repository, mm, this is the one. Pet clinic is a repo for CD job. So here what it contains, Helm chart is available and Jenkins file is available. So if you see, we already discussed about Helm charts, right? We have a separate session on Helm chart. So here by default values.yaml file is there. I removed unnecessary files. So these are important files. So that's why I kept these files, because this maintains metadata of this one, the version, the name, and this is the templates. As I said, what are the components you want to create, then all those YAML files should be available here. Here I have these many components. Inside this you can have multiple components also. Okay, so like volumes creation, jobs execution, okay, and secrets, config maps, anything, any Kubernetes objects you want to create at the time of deployment, you need to prepare a YAML file for that, and you need to put it here. Okay, so if you see the deployment.yaml file, I'm using the kind is deployment here. As I said, deployment is the kind deployment have a lot of advantages. You can do rolling update, you can do canary deployment, all these things. Okay, blue green deployment, and this is the type is rolling update. So here this is the name, labels name, and inside this, when we are deploying whatever the applications get deployed, this is a container specifications. So to that container, what are the specifications you are giving? So this is a name for the container, and I did not hard coded, uh, did not configure variables for all the fields. Basically, in the real time, we can configure. See, always we no need to come to the deployment.yaml file. All things we can put it in the values.yaml file. So here we can give in this way, but only to understand, I gave only for image. I'm telling that go and check in the values.yaml file. I'm going to update in the values.yaml file. So for anything, it will pick up from the values.yaml file. That's why we give dot values, means it will go and check in the value for the values.yaml file. So for everything, you can do variables like in scripting. While writing scripting, how you are going to write? You put all the variables, and while writing the scripting, you will give the variable to pick up from that variable. So same way key value pairs. So the same way here also we can put all these variables inside the values.yaml file, and you can give the location of that one. Okay, where exactly you can get that value. Even here one CPU also you can put it there. Dot values dot CPU limits dot CPU. That way you can put it. So every time we can just go and change the values.yaml file. Okay. So here I'm giving one CPU and 1 GB of RAM. So your virtual machines, means your worker nodes should have at least 2 CPUs. That's why I selected here T-dot medium. Why? Because which contains 2 CPUs minimum. Because if it contains only one CPU, already by default your OS might be taking some CPU, and Kubernetes components will be get created. Okay, those components might be already using the CPU. So if your application you configure with one CPU, then your application will not come online. Okay, that's why I selected T2 medium. Okay, one CPUs has been and 1 GB RAM, because for this application minimum it required. In real time, when you are deploying the application, this will be, so how we are going to configure for specific microservice, that will be provided by the developers or performance testing team. There will be two teams will be there: functional testing, performance testing. So performance testing team guys will have the capacity how much need to be allocated for microservice. Means they might be already tested the application, the legacy application. So they are aware about how much capacity will take by this specific microservice. So based on their recommendation, we will fill the details. Because as an administrators, as a DevOps engineers, we don't know how much resources will consume by the each microservice. So this information you will get it from the performance testing team, or maybe the developer application guys will know how much we need to give. Based on that, we need to provide the resources here. Okay. So this one minimum 1 GB it will take. It doesn't take one CPU. You can give 500 millicore also. But when the initialization time, means when the application initialization starting time, it will take maximum CPU, and then it will come down. So that's why I gave one CPU and 1 GB of RAM. Okay. So only thing is it's taking the values from the values.yaml file. This is the deployment .yaml file for this application. So it's pulling the image. So whatever the image we created yesterday, that image location we can give in the values.yaml file. So it will pick up that image. Okay. And coming to the templates again. So these are default files. So this, if you see these files, where if you know Go language and the values you want to give in a Go language way, means more advanced way, then you should use this helpers.tpl file, or else you can ignore that. Just general normal variable concept also you can configure, or put all the values in the values.yaml file. Okay. And this is also empty file. and it's not mandatory. Here I added the file is deployment.yaml file, petclinic-mem and service.yaml file. These are the three components it's going to get created. Okay, so if you see the service now, this is for load balancer accessing this application from the external world. We already discussed about service, load balancer, node port. So even if I'm giving load balancer, it will not get created. We need to use the IP of the node only. As I said, on bare metal here it will not get created, public IP it will not get assigned. So that's why we need to use, still even though if it is load balancer, we need to take the IP of the node port to access the application which is get deployed. And this label name you can see it, right? These are the selector label names. So this service is for that application, and this is fixed port I provided here 32750. If you don't give this, randomly it will give some port number from already discussed 32,000 to 30,000 to some 32,760, something like that. Those ports are reserved for this configuring the service. Okay, so internal application is configured with 8080 port number. So externally we are going to access it with 32750. So now this is about and let me show you the values.yaml file. So this is a values.yaml file, and if you see image and repository is this one. Okay, latest is tag is latest. We open another page. Pet clinic and templates deployment. Okay, dot values is common. Or if you are putting the values in the values.yaml file, then dot values means we are telling that dot values means go and check in the values.yaml file. And after that, if you see image repository, and this is image and this is repository. So this is the name of the repository, and tag image tag, and you can see this is the image and this is the tag. This way you need to give. Okay, so if you don't give properly here, then it will give you an error, this YAML file error. If you don't give dot image, if you give dot values dot tag, then it doesn't know where tag is there. So you should give in a sequence order this way. Let's say under tag some other option is there, like after this under the tag, it's like a child option. Then here we need to give tag dot that name, whatever the name we are giving. That way we are configuring. So all the values you can configure here. Okay, so let's say, as I said last time also, I said this is values.yaml. For example, resources I want to add. Okay, so I'll give resources to space CPU 1 and memory 1 GB. Okay, so this way I can give. So in the values.yaml, how in the deployment.yaml, how I'm going to give here, let's say here. So here if you see resources, limits is there, request is there. So what's the difference? Limit means up to this much it can go. Okay, it is not going to use that much. Request means it will need that much. Okay, means whenever you are initializing, means whenever you are deploying the pod, it expects whatever you define in the request. Okay, means if you mention here, let's say I mention here 500 millicore. Okay, and if I give 500 GB, means it will start with that. But if it is expecting more, then it can go up to this much limits, maximum limits. Maybe assume your application needs only 250 millicore CPUs and 500 MB of RAM. So here we'll give that value, and in the limits value we'll give up to what level it can go. Means slowly the application is lot of users are connecting, and it's expecting more resources. So instead of 250 millicore, it is expecting 500 millicores. Then this is a limitation. Max it can go 1 GB, 1 CPU. Beyond that, it cannot go. Okay. So even though lot of users are connecting and a lot of resource has been utilizing, it cannot go more than this one. That is the limit. So here, if you want that value separately, then what we can give here? Now limits, and this should be under this one. You should not give in this way. It should be under this one. Okay. And after that, then here request. So now give space CPU 250 millicore memory and 500 MB. Okay, so this way I can give in the values.yaml. The same thing how I can give inside the uh, deployment.yaml file. So here let's say, let me copy this. So values default. Now resources dot limits dot CPU, this way, and same thing I'll copy and I'll put it here, and this will be the memory. So from here it will take the value. Okay, so this is for limits, and same thing copy, and here not limits, it's a resource request, and same thing copy, and here memory. Okay, so values dot from resources, this is the main one. Resources, under this limits requests are there, so under the limits CPU memory. So from this way it can able to get the values. Because why I'm telling this specifically, because in your organization you are not going to give this hard coded values. Okay, this way even names, these values also will ask to do the variable configuration in the values.yaml file. So that's why I'm telling you. So it's very simple to do that. Okay, so this way you can do, and it will take it from the uh, values.yaml file. So all the things you can try. If you have enough time, you want to do R&D, so what you are going to do, you can do the same thing for all these values, like for example replicas, and for these values. Okay, and even for names also, you want to pick it from the values.yaml file. Everything you can give these values, the values.yaml, and you can try to deploy. Okay, so this is about the template. Okay, so I was talking about this will discuss later. Understood, right? So deployment.yaml, pet clinic, when this is files, as we said, what are the components would like to create, all the things should be kept under this location. Okay, like we have seen, for example, Prometheus Helm chat. If you see, lot of components will be available inside the templates directory. So go to the default stable GitHub location. If you see templates directory, these many components will get created. Config maps, daemon sets, deployments, lot of things will get created. Alert manager.yaml file will be created. Okay, so here in our example, we are just creating few things for our application to run. So you need to decide for your organization what are the things it's expecting. All the things should be under that Helm chart. So this is about Helm chart. Now inside this one Jenkins file is there. Okay, this is a Jenkins file. So this is very simple. Pipeline agent any means any machine it will go and execute this job. Okay, if it doesn't have slaves in your Jenkins, then it will execute it on master. If you want to execute it on any specific slave, then you should give the label name here. Okay, so build. So this is what just build. These all are just a commands to see in which directory we have. So this command what it is doing whenever the clone is done, so it is copying the whatever the content is inside this one, copying to the present working directory. Why? Because so let me the default directory will be the Jenkins what var lib Jenkins workspace. Let's say this is pipeline cd job. Okay, this is a job name I'm giving slash and whatever the content it's trying to clone that will be cloned here whenever the job executes. So what it is going to executing Helm pet clinic, right? Helm pet clinic. So this is what it's going to be copied. So now it contains the Helm chart, the deployment.yaml file, templates, directory, Jenkins file, everything will be available. So pet clinic, here it contains the chart, means the details, everything, the values.yaml, everything is available, even Jenkins file also. Now, the first step is star. What it will do? So the present working directory means what? It will show this is as the present working directory. Then what it is trying to do? CP this one. Okay. So present working directory will be then it will be copied. So in the present working directory, it will be copied. Means whatever this pet clinic is there, it will be copied into the present working directory. So when it is in the present working directory, means this one. This will be your present working directory, and this will be copied here. Okay. Why we are copying? Because when I'm executing Helm command, this is the chart, Helm chart name. So directly I'm giving Helm chart name because it is getting executed here. Otherwise, I should give the complete this path over here. So I don't want to give the complete path here, the absolute path. That's why I'm copying that content to the present working directory location so that I can just directly give the relative path. I hope everyone knows in Linux absolute path and relative path. Absolute path means full path you are giving. Relative path means you will go inside that path and we will do the work. Okay. So that's why this is the name of the chart. Okay. If you don't give this option, then here for reference, you need to give the complete path of the chart. Wherever the git clone has been done, the chart is available. Then you need to give this complete location. Okay. And here we are using Helm command, upgrade and install option we are giving. This way you need to give. Why? Because for the first time you are deploying, you can use install option. But all it's deployed, again you are redeploying, then it will take upgrade command. Okay, that's why we gave two options. So what it will do? If it is not there, it will install. If it is already there, it will upgrade. You install some application microservice on the cluster, it's running. Again, you want to try to, like, you got new image, and that image you provided the details in the values.yaml file, updated in the Helm chart. Again, you want to deploy that one. So again, if you are doing the same command, so if you have Helm install, means what it will do, it will give you error that already it is installed, that microservice is already installed. So separate, you need to use Helm upgrade command. So instead of executing separate commands in the single command itself, you can use in this way: upgrade -f installment. If this is the first time, it will install. If it is already installed, the deployed has been done, then it will try to upgrade the existing one. Okay, it's like redeploy. And this is a name for your microservice in your organization. What are the microservices there with that name? The naming convention should be proper. So don't give demo data or with your name in your organization for testing point of view also. So give relevant application names. So you can give in this way. If it is a dev or a UAT environment, then give that pet clinic -app -dev or UAT. This way you need to give the naming convention. Okay. So don't give how you are practicing in the lab. Don't give the same names in the organization. Okay. So here you can give up to this one. That's enough. But you can override the values which are inside the values.yaml file. Means there is some values in the values.yaml file. While executing through the Helm, you can override the values of values.yaml file. Okay. If you don't want to overwrite any values, then you can ignore this line. Okay. But if you want to overwrite it, then you can use -f set. Okay. And then if you see image.repository, this is available inside the values.yaml file. So what we are telling, if you go to the values.yaml file, actually, what is the image name here? Pet clinic image. But we don't have pet clinic image. We have pet clinic. The name itself, see, pet clinic. It's not pet clinic image. For this, we have latest tag is 1, which we built yesterday. Okay, a day ago, this is a 1, the latest tag. So pet clinic and the tag is 1. But what is configured in the values.yaml file? Pet clinic image. So this name I am overwriting at the time of deployment. Okay. So if you see here, only pet clinic is there, and -f set image.tag is 1. This way we can give override the values here. If you don't want to overwrite, then remove this line, this one, just give till here. It will get executed. And here you can give the namespace also. We already discussed in the from Jenkins server manually. We were trying to deploy some applications, Nginx. Okay, so we were using Helm command. So what we can do, -hyphen namespace. You can give in which namespace you want to deploy. That is also decided from here. Lot of other options. Not only this image or this one, whatever is in the values.yaml file, you want to override during the deployment, that values you can give it here, so that it will not take the values from the values.yaml, it will take the values from this. Okay, so this is the Jenkins file. So this is a repo. For this repo, we need to configure job. So we have a CM, and we have a pet clinic repo, right? So this is a repository is available which contains the Helm charts. So along with and Jenkins file. This information is available inside this repository. Now this is the Jenkins server. Here we need to configure a job. Okay, cd job. Now what we are going to do, go to the Jenkins, new item, um, pet clinic demo cd. This is the name I'm giving, cd job. Same select pipeline. Okay, so only you need to select pipeline script from source code management, and it's a git, and here we need to give the URL, and where is this is the repo, and this is the option to clone it. This is the repo to clone, and give this information here. So credentials, it's a public, so it's not expecting any credentials, and it's in the default master branch. This you should be careful in your organization, from which branch you are picking up. That is important. Okay, there will be difference between multiple branches, and this is the path of your Jenkins file. So this Jenkins file gets executed. Now, so as I said yesterday, whatever the path is there, that you need to provide it. Okay, otherwise it will tell file not found. It's done. So now let me build this job, and before that we can see kubectl get pods. We can see Jenkins masters and NFS only we can see. Now we'll see build now. Check the log. Okay, cloning of remote repository is done. And if you see the present working directory till job name, as I said, okay, pipeline cd job. This is my present working directory. Inside this, it's copied wherever it's cloned. This directory structure will be available, but this will be my present working directory. So what we are doing, cp Helm. So this, under this directory, whatever is there, copying to present working directory. Okay, so cp-r in the present working directory, and if you see ls-l here, this is available. And again we can check present working directory. Helm upgrade-f install command is getting executed, and this is the name which we are giving to this release. Okay, if you see release pet clinic app, and this is the chart name. Don't get confused, what is this, what is this. This is the name. This is up to you, anything you can give it, and this is a chart name. So chart name was copied to the present working directory. That's why we are telling this is a chart name, and in this chart I am overwriting some values, so to pick up some specific image. And if you see release does not exist, means this is the first time, that's why it's installed. Next time again if you install, this will be already available, so it will not tell does not exist. Okay, and whenever you execute Helm command to install some packages in the cluster applications you want to install, this will be the output. What are the resources you defined inside the template will be shown here: service account, deployment, this is HPA, horizontal pod autoscaler. So all these components will show. And you should get the success. If you do any mistakes, then it will give an error, and again you need to modify your Helm chart accordingly, and then you need to redeploy it. Okay, so now let me go and see here the same option. See, 2 minutes ago pet clinic application is running. And apart from this, what are the other kubectl get SVC for checking the service? And which one got created? This is the one, pet clinic service, and it is showing pending. It will not get an external IP, and this is the port number which we defined. Which we defined inside the service.yaml file. kubectl get HPL. This is also got created. This we'll discuss tomorrow. Auto scaling. We did not discuss the auto scaling, right? Auto scaling of pods. Did we discuss horizontal pod auto scaler?
No.
Okay, tomorrow we'll discuss. So I'll explain that. This is the one of the component got created for auto scaling. This is mentioned inside the template. That's what gets created. So what are the components or objects you define to create inside the chat? Those things will be get created. Okay.
Can we
Now,
access this application from any server or any GUI?
yes, the next step is that is the one.
Okay.
So now I'm going to access this application. So here we already created a load balancer with this port number, but we don't have any external IP to access it. And this is for internal. Inside the cluster you can able to access. So to access it from the external world, we can take any of the node IP. Okay. So let's take, if I take, this is our node IP. And give 32750 port number. Okay, this is the application, the pet clinic application is available, and find owners. If you want to add a owner, okay, last name not found, so add owner, full name, first name, okay. So it has been added, owner information, add a new pet for my owner name.
Where is created database server? So,
Database will be inside the pod. Inside
okay.
that pod itself, this pod is created, right? This one, inside that pod itself, application is running, database is also running. Basically, in real time, we have separate database, but here they are giving all together in a single application. So it will create database, and it will application will get connected to the database. And what are the information we are storing here, that will go and store in the database.
Can you show me the data like you entered?
See, that is not the part of database connecting and showing, right? So our intention is to access the application in the Kubernetes cluster. So how backend that application is connecting database, and because I'm not good at database, I don't know how to check the database connectivity, all these things. So if you know the commands, then you can connect to the pod. Inside that, you can just check database tables and entries, all these things. Whenever we are executing this, how it is getting added, that you can check database. So this is not
Yeah,
about the database part.
yeah, the source code is on GitHub. Probably you can review that. Yes.
So something like this, we can add a pet for this owner. Okay. See, now it got, when I previously I couldn't able to search. Now if with the last name I can able to search owner. So this is the owner information, and this is details like this. Multiple owners information will be available here, if who is maintaining that. Okay. So this is how we will access this application. In real time, this will be a separate microservice will be there, and this is a complete application. Your microservice, is going to, application guys will give you the URL, how to check the status of, health status of that microservice. So you need to check the health status. Okay. So if it is having any IP with any URL, any path, see inside that application, there will be path will be there to know whether application is really up or not. So that you are going to confirm. Why? Because your application might be dependent on some other service, or your application might be dependent on database, or your application might be dependent on messaging queue, okay, like RabbitMQ. So like this. So whenever it's getting started, when we deploy, so what are the prerequisites it is expecting? If everything is works fine, then only your pod will function properly and the application will function properly. Otherwise, your application will not start. So that you need to troubleshoot where exactly it is going wrong. So for that, you can check kubectl logs and the pod name you can give. Okay, so if you see here, everything works fine, then only you will get this information. Tomcat running or Java application started running. So this will be getted. If you see started pet application in 18 seconds. In real time also, if your Java application is there, it will give you that this application has been started. But if it's not started properly, then on top you can see while connecting to which dependency it is failed, you can see in the logs. Okay, maybe it's trying to connect the database, but database is not available, database is in down state, or maybe port might be not accessible, or maybe there is a network issue between your cluster and with the database, so it's not trying to reach. So there you can see the errors, logs errors. Okay, so with the help of logs you can able to troubleshoot what exactly, then you can tell to the respective, if you are not the owner of the dependency, then you can tell the application guys that due to this dependency it is getting failed. So they will help you to whom we need to contact for maybe messaging queue or maybe some other service. Let's say for example, you have 15 services and there is might be dependency. So you should be very careful that internally they will be dependent on some other microservices. Okay, some may be independent. It might not depend on any other microservice, but some microservices will be dependent. So you need to know the hierarchy, the structure of that um, microservices, which one should be deployed first, which one should be deployed second, third. Okay, otherwise due to dependency problem it will not function. Maybe seventh one is dependent on some third microservice. So without deploying third, if you're first deploying seventh one, then it will get fail. Fail means pod will not come online, it will show in the failed state. Why? Because it's trying to reach some other microservice which not got deployed on the cluster and is expecting that. Okay. So as I said, how in the config maps it will be defined the name of the other microservice to connect. So whatever the service name you are going to give, for this service we have given pet clinic hyphen service, whatever the name we have provided here, kubectl get svc. So this is the name. For other service, what are the service name will be, that will be defined inside the config maps. Okay, so that it will go and connect to that name. So if that is not yet deployed, then it cannot able to reach. So that you need to make sure dependency structure, hierarchy structure you need to maintain, which one should be deployed first, which one should be second, third. That should make a document. If you don't have, then if you already have a document, then you need to follow that. Don't deploy 15th first as the last. Okay, so it will be fail, all the things will fail. And this is very important, because lot of times I used to get issues because microservice used to have a lot of dependencies. My microservice was having dependency of database and RabbitMQ and other services. So lot of issues you used to get. Okay, and credentials, that is also important, how you are passing the credentials. with only secret option, or you have any other third party mechanism you want to use, that is also another case. So all these issues you can resolve from the checking the logs. Okay, so this is how we do the deployment through the Helm.